Good afternoon, everyone. Welcome to Physics tutorial. So in the previous video, we did um, current electricity. We gave one example. So here we want to look at another example that gives us the relationship between resistors in series and parallel and all of those. So look at the question on the board. The battery of 3 cells in series, each of EMF 2 volts and internal resistance of 0.5 ohm, is connected to a 2 ohm resistor in series with a parallel combination of two 3 ohm resistors. Now draw the circuit diagram. After drawing that, we'll calculate the effective external resistance and then the current in the circuit. So first of all, we need to look at the initials of the question, a battery of 3 cells in series. So we have 3 batteries in series, and in series we have 3 cells. So our EMF 2 volts plus 2 volts plus 2 volts. So in series, we are going to have a total of 6 volts. All right. So draw the circuit diagram for this. So we have one, two. This is 3 batteries connected in series, yeah, to a 2 ohm resistor. So here is 2 ohm. Then in parallel combination of two 3 ohm resistors, right? It's still in series with a parallel combination of two 3 ohms resistor. So this is what we have as our circuit diagram. So this 3 ohm, this 3 ohm. Now, the question says that the battery have internal resistance of 0.5 ohm. So that means if you have 6 volts for the 3 batteries, we have 1.5 ohm as internal resistance. Then 3 ohms, 3 ohms. So this is our circuit diagram. So the first thing to do is to calculate the effective external resistance, or the effective external resistance. Now remember the battery, when the battery is delivering current, it has an internal resistance of 1.5 ohm. That is combined resistance. Now, effective external resistance, not internal resistance. So to do that, we are going to find this plus. So let's start with the combined resistance of the parallel arrangement. So we have 1 over R is equal to 1 over R1 plus 1 over R2. So 1 over R1 is 1 over 3 plus 1 over 3. We have LCM here of 3. 1 times 1 is 1 plus 1 here is 1 times 1, 1. So we have 2 over 3 as our. So when we take the inverse, we have R is equal to 3 all upon 2, which is equal to 1.5. So our combined resistance for this is 1.5. Okay, right. So in series with this now, so we now have R equal to R1 plus R2, R1 plus R2. So we have 1.5 plus 2 ohms, 3.5 ohm. So the combined or effective external resistance of this circuit is 3.5. Now, the next thing to do is calculate the current in the circuit. So how do we calculate the current in the circuit? Now, the current in the circuit encompasses or includes the internal resistance. Okay, so to calculate the current in the circuit, we use V. So for B, current in the circuit. So we use Ohm's law. V is equal to IR, where I is our current. So we have that I is equal to V all upon R. And V is the PD of the battery, which is 6 volts. And R is the combined effective resistance. Now remember, the effective external resistance is 3.5, but the total resistance of the circuit, including the internal resistance of the battery, which is 1.5. So this is what we do. We say V all over R plus internal resistance. So we have V as 6 volts, our external resistance as 3.5 volts, our internal resistance as 1.5, meaning we have 6 all upon 5. 6 upon 5 will give us one whole number, 1 over 5 ampere. So this is the current in the circuit. So we're going to stop here. We follow up for the next video while we solve two other questions under this. Thank you.